In this clip, we're looking at the effect of substrate concentration on the rate of reaction. So just to remind you, our enzyme will be used in a specific reaction with a specific substrate that will bind to its active site in a lock and key model, and the products then get released in that reaction. The enzyme can be used over and over again to be able to produce the product. So for example, amylase being the enzyme reacting with starch to release sugars. So in this graph, we are looking at substrate concentration and how the level at the very left-hand side of the axis is low, and then in the right-hand side of the axis it is high. So we're looking at increasing substrate concentration. We are assuming that the amount of enzyme is staying the same, so the only thing changing is the amount of substrate. So initially, when you have low levels of substrate, there is a low rate of reaction because there's very little substrate available to combine with the enzyme. So the chances of collisions happening and the product being produced is low. So the rate is going to be low in that part. As we increase the amount of substrate, the graph continues to rise. And that is because there are more successful collisions between the substrate and the enzyme. Therefore, more product is being produced. So the rate is increasing. Then we reach a point when the graph levels off. So even though more and more substrate is being added, the level is leveling off because there are not enough enzymes available to break down the substrate. So the substrate is really having to queue up for a free enzyme in order for the reaction to occur. So at that point, we would say that the enzyme has become a limiting factor in this reaction. So those are the three parts of the graph, how it changes from low concentration to high concentration of substrate, and how the rate of the reaction will change as well.